Hi guys, and welcome to video assignment number 1. I'm Abril, and today I will be teaching you organic chemistry. The molecule name for today is 4-methyl-2-heptene, and we are going to be answering 3 questions. First, we will need to draw the line angle structure. Second, we need to count the number of carbons and hydrogens to determine the chemical formula. Third, we will need to write and balance the combustion reaction. Let us start. So you may ask, how do we start drawing the line angle structure for 4-methyl-2-heptene? First, let's take a look at the last part of the name. The prefix "hep" tells us that there will be 7 carbons present in the longest carbon chain. So let's start numbering the carbons as the outline for the drawing. 1, 2, 3, 4, 5, 6, and 7. Now let's connect the dots. Now look at the suffix "ene". This means that this molecule is an alkene, which means it will have a double bond. The number 2 in front of heptene indicates that this double bond will be located at the second carbon. Okay, so let us draw a line at the second carbon because this will indicate that it is a double bond. Now take a look at the first part of the name methyl. This implies that there is a methyl group which will have only 1 carbon. The number 4 tells us that the location where the methyl group will be placed, which is at the 4th carbon. Now let's finish this drawing and place the methyl group at the 4th carbon. Now, there it is. This is the final drawing. Let's move on to question 2, which is counting the carbons and hydrogens so that we can determine the chemical formula. So let's redraw the drawing. 1, 2, 3, 4, 5, 6, 7. And let's connect the dots. 1, 2, 3, 4, 5, 6, 7. And draw our double bond in our methyl group at the 4th carbon group. With this drawing, we can figure out and we can calculate the number of carbons. And let's keep in mind that the carbons are usually found at the ends of the line, so let's count. So there will be 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Now let's recall that carbons can only form 4 bonds, while hydrogens can only make 1 bond. With this in mind, let's start on the left side to count the hydrogens. The first carbon only needs 3 carbons since it has already 1 carbon chain. 1, 2, 3. Moving on to where the double bond is, it will only need 1 due to the double bond being located in that spot. With this third carbon, we will only need 1 hydrogen because it already has 3 carbon chains. At the 4th carbon where the methyl group is, we will only need 3 carbons, 3 hydrogens. At the 5th, we only need to draw 2 hydrogens. The 6th only needs 2 also, and the 7th carbon chain needs 3. So let's count how many hydrogens there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We also need to go back and draw another hydrogen at the 4th carbon chain. So that gives us a total of 16. Our chemical formula will be C8H16. Okay, let's write and balance the combustion reaction for this molecule. First, we should know a combustion reaction is a reaction that reacts with molecular oxygen, which is CO2, which is, I meant to say O2. In this case, our chemical formula is C8H16 was carbon and hydrogen as reactants. If the reactant has carbon, the product produced will be CO2. If the reactant has hydrogen, H2O will be produced. So the combustion equation will be C8H16O2 yields CO2 plus H2O. Now let's balance the equation. So let's rewrite our combustion reaction. So it was C8H16O2 yields CO2H2O. Let's balance the carbon first. We can first write out the before of the equation and after. So on the left side, there are 8 carbons, 16 hydrogens, and 2 oxygens. After the equation, there is only 1 carbon, 2 hydrogens, and 3 oxygens. So to get 8 carbons on the right side of the equation, we must put a coefficient of 8 in front of the CO2. Let's move on to the hydrogens. In order for us to get 16 on the right side, we must put a coefficient of 8 in front of it. Okay, now let's move on to the oxygens. Here we would multiply 8 times 2, which gives us 16. Now we add 8 plus 16, which gives us 24 oxygens. On the left, we must put a coefficient of 12 to make us have 24 oxygens. And now the carbons on the right side, there are 8 and there are 16 hydrogens. Now we have a balanced combustion reaction, which is C8H16-12O2 yields 8 CO2 8H2O. Now we have the balanced combustion reaction. Well, that is all for this video. You have now learned to draw the line angle structure, count the number of carbons and hydrogens to determine the chemical formula, and write the combustion reaction of 4-methyl-2-heptane. Thank you for watching. See you guys in the next video.